So now that we've dealt with how to do this with technology, let's talk about how to do it the old-fashioned way, paper and pencil, and then that's going to help us understand what's actually going on here too, and hopefully start to give us an idea of how we can use parametric equations. So moving forward, we're going to be solving some problems with projectile motion. Those of you who've done physics will remember the projectile motion equations, maybe. We'll be learning that and looking at some problems with baseballs being hit and thrown, free throw shots, that kind of stuff. Parametric equations also allow us to analyze things with navigation, things moving around. They're used a ton in the real world, especially when you're modeling something with software, games. So the basic idea is that instead of having an equation that says y equals and something with an x in it, now we're going to have two equations, one with x equals, one with y equals, and both equations will be in terms of t. So t is going to be the thing that changes. T will typically represent time, and as t changes, that's going to determine how x and y change. So a minute ago we used sine and cosine for y and x respectively, and we saw that circular motion because, well, that's what sine and cosine, when you put them together in an x and y coordinates, make. We'll see some different types of motion here as well. So we're basically just going to do one example today. We're going to be looking at a drone dropping a package is our situation. A drone dropping something. This drone is not on planet Earth. It is on a planet or someplace with gravity, but the gravity is not the same as Earth gravity. Well, so we're not going to get quite into the whole acceleration due to gravity yet. We're going to be tackling this lesson or this section in a couple of lessons. So we'll get all into the physics-y part of it on Tuesday next week. For right now, you can just trust me that gravity is baked into the y equation here. In this case, it would be 1, yes. So we're going to make a graph of this situation. So the situation is the drone's flying along, and it gets to some place it wants to drop this thing, and it drops it mid-flight. And the package is going to fall, and it's going to be moving in both the x and the y directions. The x and the y directions are both dependent on t, so as t changes, the x coordinate and the y coordinate of our package is going to change. Someone predict for me how high up is the package going to be when the drone drops it at time 0? At time 0, how high up is the package going to be? So how high up, we'd be looking at the y equation, right? And if I plug 0 in for t, how high up is that package going to be when it drops it? 8. So 8 meters tall, 8 feet tall, whatever. All right, so we're going to tabulate. So you guys have made x and y tables for probably since middle school. Some of you maybe before. Our t tables are now going to have 3 columns. T is going to be our independent variable, and both x and y will be dependent variables. So we'll fill out these tables the same way we would fill out any other t table. We'll just take these t values, we'll plug them into the equations for x and y and get some values. So go ahead and do that. I think we can probably pull this off with some mental math, but you've got some calculators in front of you. It is Friday, and some of you have taken a couple AP tests this week, so I will not judge you if you use your calculator. Brain's feeling a little squishy, that's to be expected. I'm hearing some good questions. Good. Eight minus 1 squared is 7. 8 minus 2 squared is 4. 8 minus 3 squared is -1. 8 minus 4 squared is -8. So let's go ahead and sketch these points. Did I make any mental math mistakes there? Are we good? Good? All right, let's do this. Sketching these points, 0, 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. 2, 7. 6, 7. 4, 4. 6, -1. I'm not going to bother with the other one. I heard some questions as you guys were filling out the table. Some people were a little concerned that my y value became negative. I heard a really good question is, did it drop this package into a lake? That would be it. That would explain it, wouldn't it? If the y value went negative. So what we would think when the y value is 0, where would you be? At the ground? Okay, so we could be dropping it into a lake, I guess, and that would cause it to go underground, or maybe this package is going to burrow underground, or maybe, like often happens in the real world, when we make a model, it doesn't exactly mimic what's going on. This equation tells us what's going to happen to the package as it falls, but it really kind of becomes invalid at this point. Let's go ahead and sketch this, though. So this curve right here would be the path that the package would take. And when we sketch these things, we're getting more than just the shape of the curve. We're also getting a direction that it travels. So this package is falling down as we go along. And when you do, in your assignment, when you graph these things, if you would stick an arrow someplace on it just so you can track what direction the point is moving as we go. So we're getting more information than just the shape. We're also getting the direction that it travels along that curve. I have some questions for you. Does anybody have any questions for me before I start asking you questions? All right. 2 questions. When did it hit the ground and where did it hit the ground? So could you please discuss with somebody sitting near you to try and answer those 2 questions? We'll come back together in a moment. When did it hit the ground and where did it hit the ground? So we're assuming it's hitting the ground at some place. There's no lake. Sorry. So I will warn you, this particular section, when we start asking these questions, this is where things get tricky. Because you've got 3 different variables that you're dealing with, and they're all interacting with each other in different ways. So I want to look at the answer to these questions kind of through 3 different lenses. The first one is kind of the quick and dirty answer by just looking at the table. If all you had was this table and this graph, let's see if we can answer this first question. Now, I came around and talked to a lot of you, and a lot of you were keying in on the question word of when. If we're asking a question about when, which of our variables are we really looking at? T. So we're looking for a value of t. To answer this question, we got to find a t value. And then a lot of you recognized that there is something special about when this thing hits the ground. What is special about the x or the y or the t when it hits the ground? What is 0? Yeah, so when it hits the ground, y is going to be 0. So basically, we need to find the t value when y was 0. And if you look at the table, what would your answer be? Yeah, so I would say somewhere between here and here, right? Y is 0 somewhere between here and here. So we could answer this question by saying between 2 and 3 seconds, just by looking at the table. between 2 and 3 seconds, this thing is going to hit the ground. Now, if I ask the question, where did it hit the ground, there's a couple ways that we could tackle this in sort of a quick and dirty way. Where did it hit the ground? How could we tackle it by looking at the table? Yeah, so it's between 2 and 3 seconds that it hit the ground. Well, the x was at 4 at 2 seconds and 6 at 3 seconds. So I'd say it's going to hit the ground somewhere between 4 and 6 meters away from the point where it dropped it, right? We could also probably answer this a little bit more accurately by looking at the graph, right? Even our sketch graph, we could answer it a little bit more accurately. I'd say it's somewhere between 5 and 6. A little closer to 6 than to 5. So we can answer these questions sort of in a zoomed out sense by just looking at the table. Let's talk about how we can get a more exact answer. Actually, let's do the most exact answer next. Okay, so to do this, and I saw some of you doing it, and you just started leading us along the right path there, Nora. So say that again. So we're going back to the when question. You said something about an equation. Yeah, so we're going to do something with our equation here. Now, if we're specifically looking for a when y equals 0, which equation should I be focused on to answer this question? Probably the y equation. The y equation is y equals 8 minus t squared. What are we going to set equal to 0? We put the y equal to 0. So 0 equals 8 minus t squared. So then we could do a little bit of algebra plus t squared on both sides. So t squared equals 8. So t equals plus or minus root 8, but minus doesn't really make sense here. So t equals root 8, which is 2 root 2. So 2 root 2 seconds. 2 times the square root of 2, and if I wanted a decimal answer, I could type that into the calculator. Why don't we go ahead and get a decimal answer here. Which is about 2.83 seconds. Now, we said a moment ago it was going to happen sometime between 2 and 3 seconds. We were right there. Let's talk about the where question now. When we say where, we know that y has to be equal to 0, and we're looking for probably for an x value here. So we're going to probably want to use our x equation. The x equation is x equals 2t. What are we going to do with that equation? Do we know the time when it hits the ground? We sure do. So we can take that and put it in for t, and we would get x equals 2 times 2 root 2, or 4 root 2. Which is about, what, 5.7-ish? About 5.66 meters or feet or whatever it would be. So part of the challenge of this is going to be which equation do I need to use and what am I going to set equal to what in that equation? Let's talk about how to do this graphically. Could you guys go back into your calculators and let's put this parametric system into our calculator. So we've got 2t and 8 minus t squared. And please resist the urge to hit the graph button, because we want to adjust our window first. I don't know why, but I lost my little bubble here, so I'm going to get back my bubble with the tail. Let's go to our window. Our window, t is going from 0 to 6. We don't need it to go that far. Our table only goes out to 4 seconds, so I'm going to change that. My x-min is going from negative 15 to positive 15. Does it need to go that far? Not really. I don't know. Negative, what do we want? Negative 10 to 10? All right, sounds good. And does my y need to go all the way down to negative 10? We want it to go from 0. Do we want to show a little bit of negative? No negatives at all. Let's show a little bit of negative just so we can see where it crosses the x-axis. I'm going to go down to negative 2. Max is 10. All right, so let's graph this. Let's watch this package fall out of the sky here. And to me, that's really cool. For those of you who took physics, that's neat because you can actually see it accelerating, right? You can see it getting faster as it goes along. Shh. Now, I wanted to get a look at this, but I also want to use this to try and answer these questions. And a couple of you were playing around with this to try and answer this when and where question. You guys were looking at the x-intercept here. And what was the calculator function that you were attempting to use to find this? What was that menu that you showed me? The calculate menu? That's where we used, when we were doing functions, we used that to find x-intercepts, to find maxes and mins and all that kind of stuff. But if you go into second calc, we've got value, but we don't have any of that other stuff. And all of this is calculus stuff. You'll learn about this next year. So it's not giving us options to do intercepts. So if we wanted to do this, and guys, I really need your attention here. You do not want to miss this, okay? This is where things are going to start getting messy for you when we start getting into more complicated problems. If I want to answer this question about when did it hit the ground, I'm going to have to actually move out of parametric mode and focus in on just one of these equations, okay? So it's really important that when you read a question, that you ask yourself, what variable is it asking me to find, and which equation is going to help me find it? We know that we're trying to find t, and we know that we're going to use the y equation, okay? So go ahead and, in your calculator, go back to your mode and switch back to function mode. Go into y equals, clear out anything that's there. We're going to focus on one of these equations, the x or the y. We said that we would need to look at the y equation. So I'm going to type this in, 8 minus t squared. 8 minus t squared. Oh no, it put an x in place of my t. Are we okay with that? Okay, we just have to remember that this x is different from this x. This x is representing t. Okay, this is where things get a little messy, all right? All right, now if I graph this, am I going to see the same shape that I had here? Maybe, maybe not. Okay? In this case, it's not going to look exactly like it. What we are looking at is just a graph of the height of the thing. Instead of versus x, like we have here, the y or the x-axis is going to represent time. So I'm going to go ahead and do zoom 6, my zoom standard window. And I'm going to look, and I do see a parabola. But notice that the x-intercept is not in the same place that it was a moment ago. It's not between 5 and 6. It's somewhere between 2 and 3. And why is it somewhere between 2 and 3? Because that's the time when we said it was going to be hitting. So we could now use our calculate menu. So you guys were on the right track. You just needed to focus in on one of the equations. We can now use our calculate menu to find the 0, or the x-intercept, where that happened, and that's that whole left-bound, right-bound guess thing that hopefully we still remember. If not, go back and look at the notes from chapter 3. And I'm coming up with the exact same answer that we did just a moment ago, about 2.83 seconds. The question is, should we use intersect? We can only use intersect if we have two functions going on. So if you graphed a second function that said y equals 0, you could use intersect. Or you could just use the 0 option in the menu. All right, so let me show you something else neat. If you've been following along with me, if you quit out to your home menu and you hit the X button and you hit enter, you should see that same X value that you just found, which is super useful. Now, here's the problem though. If I'm in my graph and I move my cursor around at all, and I go back and I hit X, it's not the same anymore, okay? So as soon as you do anything that moves your cursor, it's going to change. But if I come back, let me just find my 0 again. Left bound, right bound, enter. If I quit out of this and I go back to my home menu and I hit X, I've got that same value stored in there. And that's useful because we can use that now to answer the second question, which is where did it hit the ground? We know it's going to hit the ground at 2 times whatever t is. Well, this is the t value, so I can just type in 2x, and I'm going to get that answer to that second question. Okay. Most of your work today is not going to be focused on answering these questions about a specific situation. It's mostly what we're going to be tackling on Tuesday, but I wanted to give you a preview of it today. And I hope that you guys will pay attention and take it seriously, because I'll tell you that this is something that my students have struggled with in the past. It's not difficult. It's a matter of, do you know what to look at, right? There's kind of 3 different things going on right now. There's the graph that we made where we put X and Y together. There's also an X graph and there's a Y graph. And to answer different questions, you might need to be looking at one of those or the other. So figuring out which of those to look at and which function to use is going to be the big challenge. Okay, we have one more thing to do, and then we'll wrap this up. This one's pretty straightforward. You'll be practicing this. So this will mostly be the work that you'll be doing in your assignment today. So eliminating the parameter is something that we do sometimes with these parametric equations. Sometimes it's useful to know what the shape of our path is going to be as a function of y and pulling x or pulling t out of the whole thing. So essentially what we're going to be doing is we're going to be combining our x and our y equations together into a single equation that does not have a t anymore. It's only going to have x's and y's. Taking time out of the equation. When we do this, we're going to retain the shape of the path, but we're going to lose the direction that it travels and how fast it travels. It's going to be a bunch of points that will form a curve, yes. This is the same set of parametric equations that we just did a moment ago. If you had to guess, based off of the graph that we sketched a moment ago, what shape do you think we're going to get when we eliminate the parameter here? Does it kind of look like a parabola? So we're expecting to see an equation that resembles a parabola. Let's see if we can do it. So this is a relatively simple process. We're just going to take one of our equations and isolate t, and then we'll substitute into the other equation. And it doesn't matter which one you pick to isolate t, but there's oftentimes a simpler path. In this particular problem, which equation looks easier to isolate t? I'd say the x equation looks easier to get t by itself. We could get t by itself here, but we need to do a square root to get rid of that square. I'd say let's stay away from that. So let's take this x equation and isolate the t. We can do that really simply with one step of algebra. And we're going to get t equals x over 2. And what are we going to do with that x over 2? We're We're going to put it into our other equation in place of the t, and then we will have an equation that no longer has a t, only has x's and y's. That's it. We'll talk about simplifying these. Some of these we'll be able to simplify a little bit, but this is fine. I would probably simplify this a little bit. Equal or minus, so minus not an equals. This is x squared over 4. If I wanted to make it look more like a quadratic, I could write it as negative 1/4 x squared plus 8. Is all that necessary? No. Are you seeing how x squared over 4 became 1/4 x squared? Negative stayed with it. I put the 8 at the end. This is going to be definitely a parabola opening. Oh, thank you very much. Just on that back cabinet. In the nurse's office? Okay. 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 We'll deal with their stuff here in a minute. Okay. We said this is going to be a parabola opening downwards. Yep. With a y-intercept at 8. Let's graph it. I think we are still in function mode, aren't we? Yeah. So we've created a function. This is no longer a parametric equation. We've created a function out of this. So let's graph it. Negative 1/4 times x squared plus 8. And I'm going to go back to my standard zoom window. So instead of typing graph, I'll do zoom 6. And what I'm expecting to see here now is the exact same shape that we had a moment ago when we graphed it, and it is. So this is showing up here, this is where the drone dropped the package, this is where it hit the ground. What we're losing is we no longer get a sense of which way it's traveling, and we've also got this negative portion over here that didn't really make sense in the context of the situation before. But it is the exact same shape. All right, so what you're going to be doing today, you'll be doing some problems where you will be just playing around with graphs and getting windows to match what you see. You'll do some where you're going to be making some tables and graphing by hand like this. And then you'll do some problems where you're eliminating the parameter. I do want to get started on the assignment together with you right now and give you some hints to make this go a little bit more smoothly at the beginning. So if you guys could get out, if you've got your book, get your book out. If you do not have your book, that's okay. Go ahead and get out whatever you're going to do your assignment in, and I'll walk you through it. Let me put the assignment up here so you can write it down. I don't know why I wrote it as A 6.3. Oh, assignment 6.3. Let's call this 6.3A because we are going to have a couple 6.3 assignments. 1 through 4, all 5 to 25 odd. We're going to look at a couple of these together. I'm going to get you started on them. So I'll put the book up here in just a moment.